Welcome to Sundar's lecture. This is lecture number 8, and in this lecture we are going to see M notation, that is what is min terms and then what is max terms, and how those min terms and max terms can be represented in boolean algebra, right? So in the previous class, what are all the topics we have seen? See, representation of logic functions. We have seen two different representation. One is sum of product and another one is the product of sum, and we have seen what is canonical form or the standard form, and how to write the boolean expression in canonical form and in the standard form, and what is the procedure, and we have used the distributive law, right? So now we have seen this one, right? Up to this we have seen in the previous class. For example, if I take another one for POS, for example, the shortcut method. See, I have told you what is the shortcut method for SOP. But for example, if you take an exam and boolean expression, let it be A, B, C, D, four variables. Let maybe I will give like A plus B bar, because this is POS function. It will come like this, right? Plus C. This is one thing. Dot A bar plus B plus D bar. Anything it may be, and then dot A bar A plus, not A, maybe you take it as B plus C bar plus D, and you need to get this whole boolean expression into canonical form. How will you do that? So you have to put a dot and then put a plus, and then you have to C plus C bar. You have whatever the term we have missed here. See what we seen here, conversion of POS. What you need to do, if you miss any term, then what you need to do, you have to put plus. In the bracket you have to put C dot C bar, because this is a fallacy. It will be 0, so that this expression will exist again. So by using distributive law, again what we have done, we have just added everything, right? So that is what, sorry, here we have added everything. But in shortcut method, what you do, you can easily do this. See here, if what is the missing term here? What is the missing term? D is the missing term. So what you do, this term, for this particular term, I will write here. Maybe I will straight away write. No need to write separately. A plus B bar plus C plus, you put D straight away, plus D in this function, and then dot. Again what you do, A plus B bar plus C plus, you put D here. Now you put D bar. That's all. That's all. It has converted. Right? We have converted. Now you put dot. Again, what is the missing term here? C is the missing term. So what you do? A bar plus B plus C plus D bar here. Whatever here, I have just added C. And then put dot. You have added C here. Now the next term should be A bar plus B plus, you put C bar now. C bar plus D bar. That's all. That is the second term. You have converted this one, and you go here. The missing term is A here. So what you do? A plus B plus C bar plus D. That is the next term. And put dot. You put A. So now what you need to put here? It is A bar plus B plus C bar plus D. That's all. This is the canonical form. No. You have to see whether two terms are the same thing. See here, this is a different term, this is a different term, right? So here it is A bar, here it is A bar, it is A bar. Here you see anything is same? No. B bar is here, it is okay. Then this term will exist. This term will exist, no problem. And then you compare this one now. A is here, B bar is here, right? So no problem whatsoever. So this is also term, existing term. Here it is A bar plus B plus C bar D, A bar plus BC plus D bar. Anything is same here? If you see, no, right? So this is an existing term, and this is an existing term, because only here you see A bar plus B plus C bar plus D bar is here, right? So D bar, no problem, no problem. So this is an existing term, a separate term, right? No common term. No term is like this, anything behind this one. So this is a separate term, this is a separate term. So this whole thing is a canonical form, is in canonical form, right? For example, if any two terms are same, then you have to write only one term. Should not write two terms, right? Because what is the procedure? A dot A will be is equal to what? A. That is the law we have seen already, right? So this is how you need to convert. Shortcut method. Just put one term and then if any term is missing, then put plus D and dot put write the same term plus put the D bar and whatever missing here. So this is very simple to understand, right? So you can do this. Right. Now what we will do, we will go into M notations. Right. What is M notation and what is the use of this M notations? Right. So first, what I do, I will take a three input system. Say I am not skipping anything. I will draw with my own hand so that you can easily practice down. Right. So three input input system means what you have to do. You have to put A and then B and then C, right? This is the three input system, right? First thing, what I will do, I will write here it as the min term. So min terms, always they will represent in small letter m, right? Small letter m. And you have to go for max terms. And always they will represent it in the capital letter M. This is the whole idea, right? So I will put the tabular column. Right. Now I have tabulated it. So if it is a uh, three input system, then what you will do now? 0, 0, 0, 0 is there. Four zeros and then 1, 1, 1, 1 will come, right? Then it will be 0, 0, 1, 1, 0, 0, 1, 1. Then this will be 0, 1, 0, 1, 0, 1, 1, 0 and then 1, right? So this is the three variable system. And now what you do, you have to write like maybe you have SOP and then you have POS, right? So in SOP, how will you write the terms? It will be ABC and then plus A bar BC and then you will write like this, right? ABC bar, it will be going on. And if it is a POS function, then what you will do, you will write like A plus B plus C and then this whole term dot A bar plus BC plus C, like you will write like this, right? So now you just take these terms, like these terms, right? What you do now, you put bar for zeros and 1 as the normal term. For example, you see here A, B, C, everything has bars, right? So what you do now, you just try to write this as A bar and then B bar and then C bar. That's all. And then you see here AB has zeros and C has 1. So what you do, you write A bar, B bar and then C. That's all. And you see here A and C has zeros, right? So A bar, this will be B and then this will be C bar. And only A has 0, so it will be A bar, this will be B, this will be C. And you see here only this term is the whole thing. So B and C has the 0, so it will be B bar and then C bar. Here it is A, B bar, C, and then here it is A, B, C bar, and then here it will be A, B, C. Right? This is the whole idea. This is the whole idea. And you write for max terms. What you do now, for max terms, if there is any one, then put bar. If there is any one, then put bar. So here you see here everything is 0. So it will, like, you have to write like this term, these terms, A plus B plus C. Try to understand, right? Plus. So if you see 1 here, see here, you have to write this as A plus B plus. See here 1 is there. So what you do now, put bar. For 1 you have to put bar in max terms. For zeros you have to put bar in the min terms. That is the whole idea, right? And now what you have to write here, it will be A plus B bar plus C. So whatever this term has, it will be inverted. See here, if you get bar here, you will get the normal term. If you see any normal term here, you will get bar. So you can easily write from here. So this will be a plus b bar plus c bar, and then this will be a bar plus b plus c. Same thing. You have to simply write. So this will be a bar plus b plus c bar, and then here it will be a bar plus b bar plus c, and then here it will be a bar plus b bar plus c bar, right? So now this is the whole idea. You have to write like this, right, for min terms and then for the max terms. And what is the exact meaning of this? What actually it is coming down? You see here, this is a bar, right? A bar dot b bar dot c bar, right? So you take this term. I will write it here. So what you will get for a bar plus b bar plus c bar, which should be is equal to, see here it is 0. So a bar will be 1. So dot, it is 0, b bar will be 1 dot, it is c is 0, so c bar will be 1. So what you will get? You will get as 1. If you multiply everything, 1 dot 1 dot 1 will give you what? 1. And you take this term, like I will write here it as 1, right? And then you see here, it is a bar is 0, so it will be 1, b bar is 0, so it will be again 1. So C is 1, so maybe I will write it down here so that you can easily understand. So this will be is equal to, see here, these two are 0, so it will be 1 dot 1 dot, and C is already 1. So this will be 1. Try to understand, right? So if you write all these terms, you will get 1. You will get 1. You will get 1. You will get 1. See here, everything is ABC. So everything 1 dot 1 dot 1 will give you 1. So the thing is, I will write here min terms, min terms, min terms always results in 1. That is the whole idea. See, this one results in 1. That means the high, always true functions, right? That is the whole idea you have to understand for the min terms, right? And then if you are going for max terms, you see here it is a plus b plus c. 0 plus 0 plus 0 will give you what? It will be 0. It will be 0. So now you take this one, a and b are 0. So 0 plus 0, c bar is here. So this becomes 0. So 0 plus 0 plus 0, again it becomes 0. So I will write down here anyhow. See here, a plus b plus c bar, and the values are 0, 0, 1, right? So if you put for 0, this will be 0 plus c bar, then it becomes 0. So everything added, finally you will get 0. So if you do so for all other terms, everything will result in 0. Everything will result in 0. So the idea is max terms always results in 0. So this one I will write here, results in 0. So you see here, while representing the these terms, that is min terms or these SOP terms, we say that in K-map we will always put one. I will explain you what is K-map and how to represent the Boolean expressions in the K-map. And if you are going for POS function like these functions, added functions, max term functions, then always we will use zeros in the K-map. That is why that the basics of that one come from here. So this is the M notation, that is min terms and the max terms, right? So how it is related to the Boolean algebra, and how we are going to represent this one in the Karnaugh map. That is what we are going to see now. One term, I have missed this one. See here, always what we will do, since this is small m, we represent these terms as this one as m0 and this term as m1, small m. This is m2 and this is m3 and this is m4, this is m5 and this is m6 and this will be m7. And the max terms, how can I represent? This is capital letter M, so this will be capital letter M1, capital letter M2, and this is capital letter M3, and this will be capital letter M4, this will be capital letter M5, and M6, M7, M8. So if you see small m's, then you have to defaultly understand that this is min term. And if you see the capital letter M, then you have to understand defaultly that is the max terms. That is the whole idea. See here, I have written it for 3 input system, and you can also write it for 4 input system, 0, 0, 0, 0. And what you will have as the min term, A bar, B bar, C bar, D bar. And what you have as a max terms, A plus B plus C plus D. Likewise, you have to write for 16 combinations, right? If it is a 4 input system, then it will be a 16 combination, right? So then what we will do now, for example, I will take an example now. Example. We have a boolean expression like this. Huh? We have a boolean expression f of a comma b comma c, three input system. If they have given you like this, then it will be three input system, will be is equal to a b bar c, and then plus a b c bar, and then plus a b plus a c plus b c bar, right? We have a function like this, represent this, represent boolean function in minterms. So this is the given question. Try to understand. If they have given you like this, see here, whenever you need to represent a boolean function or boolean expression in minterms or in max terms, then that particular function should be in canonical form. If it is not, then you have to convert that particular function into canonical form. See here, this is not in canonical form, right? These two terms, no problem. But these three terms have missing one particular variable. Then we have to convert that into canonical form. So first you convert this into canonical form. First you convert. So f of a comma b comma c can be written as, see these two terms I don't need to do anything. So a b bar c plus a b c bar. I will go fast now because we know how to convert into canonical forms. We have already seen these kind of things. So what you need to do here, you have to write a b c first for this term, and then put a b c bar. That is the second term, and plus b is missing term, so it will be a b c. This will be a b c plus maybe I will write down ABC, first term I have written, then it will be A B bar C plus. So I have written for this. Now this one, it will be A B C bar. B C bar has to be same, and you have to add A here, and then plus this will be A bar B C bar. Right now this is the whole term, and you have to see whether two terms are same. See here, A B bar C here. Anywhere else A B bar C you have a, B bar, C, C here. Both terms are same. So this will be eliminated, right? So no other terms, right? Then you have to see A, B, C bar. See here, A, B, C bar. Here is one term. So you have to write this one. Here is one term. So you have to write this one. So you have to cancel this one. A, B, C bar. Again you see here. Here there is a B, C bar. So you leave this one. Next one A, B, C. You see here. A, B, C is here. So I am going to write this. But you have to neglect this one. A, B, C should be neglected. And the other term is this one finally. So the function of a boolean function of ABC, the canonical form will be a b bar c plus a b c bar plus a b c plus a bar b c bar. So this is the canonical form. Try to understand. This is the canonical form. Right now, what you need to do, you have to represent this boolean function in min terms. Why they have given you min terms? Because this is a SOP function, right? That is why they have given it as the min terms. If it is a piecewise function, then they would have given it as the max terms, right? Now you see, what is this one? What is this one? What is this one? You have to know these kind of things. See here, go to this slide. Now you have to see for A, B bar, C. What is A, B bar, C? A, B bar, C is here, right? So what is this term? This is actually M5. So come here, you write this as M5, M5. And what is A, B, C bar? A, B, C bar, it is here. What is this term? It is M6, right? So this term is M6. And ABC is M7, right? So this will be M7, right? And then A bar, BC, A bar, BC. Where is A bar, BC? A bar, BC. It is here. What is this one? M3, right? So this will be M3, right? Try to understand. Now, we can write these type of terms in such a way. See, we can write like a function of a comma b comma c. Always we try to notate these kind of things like summation, because these are all added things, right? This is added, this is added, this is added. So what we will generally do, we use this term summation. These are all min terms, so I will just write min terms, summation of min terms in bracket. First you can shuffle this one, because 2 plus 3 uh, will be always same as 3 plus 2, right? So you just write this term, that is 3 comma this term 5, that is 5 comma 6 is here, this one is here, and then 7. That's all. That's all. This boolean function can be notated in min terms like this. This is actually min term. This is actually min term. Try to understand. Try to understand. This is the whole idea. You have to be very careful while writing these kind of things. They will give you questions like this. They will give you questions like this. Function of a comma b comma c, summation m 3 comma 5 comma 7. Then you have to understand that these three is represented like this, a bar b c, and 5 representing a b bar c. You have to know, but you have to write this one and you have to convert like this. So we have represented the boolean function in terms of min terms. Right, now we will take another example. Like it will be now POS function. For example, a function of a comma, maybe I will write down the question. So now this is the given question. See, function of a comma b comma c, and they have given some terms, right? POS function, and you have to represent this boolean function in max terms. In max terms. So what you have to do, you have to convert this into canonical form, because this is not in canonical form, right? So what you do, you just convert this one. So first two terms, no problem. So it is a plus b plus c, not an issue. So you can put dot, and then a plus b bar plus c, there is no issues, put dot. And now for this one, missing term is c, right? So what you need to do, a plus b plus c, first you have to put, and then put dot, then again a plus b plus, you have put c here, then you have to put c bar, that's all, dot. And then you see here a is the missing term, so what you need to do, you can put a plus b plus c dot. So again a is there, you are adding a, so it has to be a bar plus b plus c. So this is the whole idea. And now you have to see whether two terms are the same. So it will be a comma b comma c, that should be is equal to, see here a plus b plus c here, it is there, and then you see here another a plus b plus c here. A dot a will be what? A, right? So you can write once. So this will be a plus b plus c. Here also it is a plus b plus c. So a dot a will give you what? Again a. So you can neglect this term. So this one is written, and then dot. So you can write this one now. A plus b bar plus c. You can straight away write. So I will tick this one. Any terms is like this one, a plus, no, right? No same terms. And then this term can be straight away written. So this will be a plus b plus c bar, right? And this term is not the same one, so you can put dot, you can write this also, that means a bar plus b plus c. So now this is the canonical form, this is in the canonical form, right? So now what you do, you have to get what is the max terms for these one, right? So what you do, you go here, a plus b plus c, what is the max term? A plus b plus c, it is here, max term is m1, right? So m1, so this term this term is m1, capital letter m1, which means that is max term, and a plus b bar plus c, a plus b bar plus c, a plus b bar plus c, this is here, and what is the max term? It is m3, right? So this is m3, and a plus b plus c bar, a plus b plus c bar, a plus b plus c bar, see here, a plus b plus c bar, a plus here a plus b plus c bar, what is that? M2. So this will be M2. And what is this one? What is this one? This is a bar plus bc, a bar plus bc, a bar is here plus bc is here. What is this term? This is M5. This will be M5, M5, right? So what you have to write this term, this will be function of a comma b comma c. See here, we will use a different one. Here we have used summation because these are all added things, right? These are all added things. So I have used this as the summation term. But now here I will use term like this symbol. This is a multiplication symbol in Boolean functions. Multiplication of capital letter M, because this is the max terms, in bracket. I have to write all the one. M1 is there, so I can put, don't you need to put M1, M2, M1, comma, no, you don't put, like you directly put numbers, 1 comma, 2 is here, 2 comma, 3 is here, 3 comma, and then 5. That's all. That's all. See here, I have represented this whole Boolean expression in terms of max terms. This is max terms. If you see pi m, pi capital letter M, then you have to understand this is the POS function. This is a POS function, and this is very important. This is actually POS function. If you see anything like this, and this is SOP function. If you see any summation of small letter m like this, these are all basic things, very basic things. And I will tell you one thing now. The SOPs and POS functions are invert in nature. If you take a SOP function, then that will be the direct opposite of POS function. Anything it may be. Anything it may be. Maybe. You see here, why this is happening? See here, this always results in 1, this always results in 0. That is the whole idea, right? So now you can easily do this one, right? So you can convert any Boolean function into min-term function and then max-term functions, right? So now what are the topics we have seen in this particular class? We have started with the M notation. What all the M notations are there? There are two M notations. One is min term and one is the max terms. We have taken 3 input systems, and in 3 input systems we have written the expressions for min terms and for max terms. In general, the behind min terms, the SOP functions will come, and behind max terms POS functions will come. So we have written all these kind of things, and we have concluded that min terms always results in 1, max terms always results in 0, right? And then we have gone for an example expressions. We have taken 2 Boolean expressions, and in that we have seen these expressions can be written like this one, like min terms, and then we can write this function POS function as the max term functions, right? So we will see Karnaugh math basics in the next class. Thank you.